Section 7.3, polar coordinates. So the first thing we're going to talk about is the polar axis, which is what we see down here. This polar axis has a pole, and the pole is here in the end here. Now, the way we view this in most cases isn't just this way. We usually think about the idea of the unit circle when we're talking about the idea of the polar axis. What I mean by that is, so the way we generally see this is taking this polar axis and placing it on this unit circle idea. That's in general how we deal with the idea of the polar axis for us. And generally we'll say, hey, if we're going in the positive direction for theta, we would go around this way. Or if we had a negative direction for our angle, we would go around this way. So those ideas are what we're talking about here when we're talking about this idea of the polar axis. And that is the polar axis right there. And I don't know if you knew that before or not, but now you do. So this right here is my polar axis. In the centers here, this is still the pole. So there we go. That's really what we're looking at here when we're talking about the idea of these polar coordinates. So now let's say, for instance, I gave you the point, let's call it 3, 5 pi fourths. Okay, so the way this works, this is my r, this is my theta here. So what I would do is I'd go around to 5 pi fourths. So I'd go all the way around to there. Because if I think of pi, pi is 4 pi fourths, and that's pi, because if those cancel, I just get pi. So then it's one more than that, a pi fourths more, so it's going to bring me over here. So then once I go all the way around here, then it's telling me that my radius is 3. So that means I would go out in this direction here, 3. So then my point would be right there, and I would call that point A. So now let me give you another point here. So let's take point B, -4, and let's go with 7 pi fourths. Okay, so that means I'm going to go all the way around to 7 pi fourths, which should take me to about there, because that would be 315 degrees, and you see the 7 pi fourths here. Okay, and then it says -4. So that means in general, if it was positive, I would come out this way. Since it's negative, I'm going to go in the other direction, but still on the same line. So I'm going to come out 1, 2, 3, 4. So my point is going to be right there, and we're going to call this B. So now we have our A and our B. So that's how we graph points. And now we know the polar axis if we didn't before, and the center is the pole. So now we understand all that information. Now we're going to move on to the not the parametric, but the polar equations. So now let's just take a point. Doesn't matter which one it is. I'm going to take this one, let's say there. Okay, and I'm going to say if I go out 4, 1, 2, 3, 4, that this is going to be 1 here. Ooh. And for now, I'm just going to call this point r theta. So what I'm going to do from here is I'm just going to create a triangle coming from the pole here out to that point and down to the x-axis. So that'll result in this triangle here. And we can say that this angle here is angle theta. Okay, and if I think about this distance here along this side, this distance is going to be my x. And then if I think about this distance here, this is going to be my y distance. So then if I think about how I could talk about x, theta, and r of some sort, my r would be over here. Okay, that would be my radius coming out from the pole. Okay, and if I think of like the sine of theta or the cos of theta, I could say the cosine of theta equals opposite, nope, not opposite, adjacent over hypotenuse. And if I think of this triangle over here, that means it would be x over r. So adjacent over hypotenuse would really be x over r. And if I solve this equation for x, I would get x equals r cosine theta. And then similarly, if I did the sine of theta, that would be y over r. And then if I solve that one for y would equal r sine of theta. And then I can also think of the Pythagorean theorem for this same triangle here. And I could say that x squared plus y squared equals r squared. And I could also say the tan of theta equals, and that's opposite over adjacent, so that would be y over x. And these are actually the four equations that we use when we talk about polar coordinates. Because in most cases, well, not in most cases, but in some cases, we're converting back and forth from polar coordinates to rectangular coordinates. And rectangular coordinates are just x's and y's. Polar coordinates are r's and thetas. So this is really the idea of what we're dealing with here, and this is really just the core of it all. So from there, we'll be able to do a bunch of different types of problems just using those equations and also the idea of the graphing that we did just a few minutes ago.